Welcome to day 16 of Daily AI Wizard, my incredible wizards. I'm Anastasia, your thrilled AI guide, and I'm absolutely buzzing with excitement today. Have you ever wondered how AI can learn to see, hear, or even understand language just like a human brain? We're diving into deep learning, a powerful evolution of neural networks, and it's going to be a magical journey. I've brought my best friend Sophia to share the excitement. Over to you, Sophia.
Hi, I'm Sophia, and I'm so thrilled to join you today. Deep learning takes neural networks to the next level, unlocking AI's ability to tackle complex tasks like image recognition or natural language processing. It's like giving AI a deeper, more powerful brain, and I can't wait to show you how it works. We've got a spellbinding demo coming up using Python to classify customer churn. It's going to be absolutely amazing. Let's dive into this adventure together and uncover the magic of deep learning.
Let's recap day 15, where we explored neural networks. We learned how they mimic the human brain, using interconnected neurons to process data. We covered layers, weights, and activation functions, which help the network learn patterns. We trained them using backpropagation and gradient descent to optimize predictions. We overcame challenges like overfitting with smart solutions to improve performance. And we classified customer churn with a fantastic demo. Now, let's go deeper with AI. I'm so excited for deep learning. Today, we're diving into deep learning, and I can't wait to explore this with you. We'll uncover what deep learning is and its role in AI advancements. We'll learn how it extends neural networks by adding more layers and complexity. We'll explore key concepts like deep layers and specialized architectures that make it powerful. And we'll train a deep model with a magical demo to see it in action. Let's unlock deeper AI magic. This journey will be incredible, I promise. Deep learning is our star today, and I'm so excited to share its magic. It's a subset of AI that uses deep neural networks with many layers. These many hidden layers allow it to learn complex patterns in data, far beyond simple models. It excels in tasks like computer vision, speech recognition, and natural language processing. For example, it can recognize faces in photos with incredible accuracy. Deep learning is inspired by the brain's deep structure, making it a magical leap in AI power. I'm thrilled to dive deeper. Let's compare deep learning and neural networks, and I'm so thrilled. Neural networks typically have a few layers, suited for simpler tasks like basic classification. Deep learning uses many layers, tackling complex tasks with greater depth and accuracy. It's better for things like image recognition or natural language processing, where patterns are intricate, but it requires more data and computation power to train effectively. For example, a deep network can power language translation systems like Google Translate. It's a magical evolution in learning. I'm so excited to explore it. Why use deep learning? Let's find out. I'm so thrilled to share its benefits. It handles complex, non-linear patterns in data, capturing relationships other models can't. It's great for big data and datasets with many features, scaling well for large problems. It automates feature engineering, like extracting edges in images, saving us time. For example, it can detect objects in self-driving cars, ensuring safety on the road. Deep learning often outperforms traditional models in accuracy, making predictions more reliable. It's a magical tool for modern AI. I'm so excited to use it. Let's see how deep learning works, and I'm so excited to break it down. It stacks many hidden layers of neurons, creating a deep architecture for learning. Each layer learns different features, building complexity as data passes through. Lower layers detect basic patterns like edges or shapes in images. Higher layers combine these to recognize objects or concepts, like a car or a face. It's trained using backpropagation and gradient descent to optimize predictions. It's a magical hierarchy of learning. I'm thrilled to understand it. Deep learning has key architectures, and I'm so eager to share them. CNNs, or convolutional neural networks, are perfect for images, capturing spatial patterns like edges. RNNs, or recurrent neural networks, handle sequences like time series or text, remembering past data. Transformers power language tasks, like those in ChatGPT, understanding context in sentences. For example, a CNN can classify images, identifying cats or dogs with accuracy. Each architecture has its own magic, suited for specific tasks. Let's explore their powers. I'm so excited. Here's an example, using a CNN for image classification with deep learning. We use data with images of cats versus dogs to train the network. The CNN learns features like edges and textures through its layers, identifying key patterns. Convolution and pooling layers extract and reduce these features, making processing efficient. The output layer predicts cat or dog with high accuracy, classifying the image. It's a magical way to see patterns. Deep learning really shines here. I'm so thrilled by its capabilities. Let's look at another example, using an RNN for sequence prediction. We use data like a time series, such as stock prices, to train the network. The RNN remembers past data in the sequence, using its memory to understand trends. It predicts the next value in the series, like the stock price tomorrow. This is useful for text, speech, or any time-based data capturing patterns over time. It's a magical way to handle sequences. Deep learning's memory power is amazing. I'm so excited to see it in action. Training deep neural networks is fascinating, and I'm so excited to share. The forward pass sends data through the layers, making a prediction at the end. We calculate the loss by comparing the prediction to the actual value, measuring error. The backward pass, or back propagation, adjusts weights to reduce this loss across all layers. We optimize using gradient descent with a learning rate to control updates. With more layers, more computation is needed, but the results are powerful. It's a magical training journey. I'm thrilled to learn it. The vanishing gradient problem is a challenge in deep learning, and I'm so determined. In deep networks, gradients can become tiny as they propagate back through layers. This slows or stops learning in early layers, making training ineffective. It's common when using activation functions like sigmoid, which squashes values. We can fix it with real U activation or better weight initialization techniques like Xavier. It's a challenge for deep magic, but we'll overcome it. Let's solve it with AI tricks. I'm so excited. Overfitting is a big challenge in deep learning, and I'm so eager to tackle it. The model memorizes the training data instead of generalizing to new data. This is common in deep networks with many parameters, which can fit noise. Signs include high training accuracy but low test accuracy, showing poor performance. We can fix it with dropout, regularization, or by gathering more data to train on. We need to keep our deep magic balance to avoid overfitting. Let's ensure our model generalizes. I'm so excited to fix this. Let's fix overfitting in deep learning, and I'm so thrilled to share solutions. Dropout randomly disables neurons during training, preventing over-reliance on specific paths. Regularization adds penalties like L1 or L2 to the loss, discouraging complex models. Data augmentation increases data variety, like rotating images, to improve generalization. Early stopping halts training when test error rises, avoiding overfitting. These are magical solutions for better, more robust models. Let's make our deep magic strong. I'm so excited to apply these. Deep learning requires the right hardware, and I'm so eager to share. It needs lots of computation because of the many layers and parameters involved. CPUs are slow for large, deep networks, taking too long to train effectively. GPUs offer faster training with parallel processing, handling many calculations at once. TPUs designed specifically for AI are even faster, speeding up training further. For example, training on a GPU can drastically reduce time for deep models. Magic needs the right tools. I'm so excited to explore this. Deep learning frameworks make our work easier, and I'm so thrilled. TensorFlow is popular, flexible, and backed by Google, great for production. PyTorch is dynamic, making it ideal for research with its flexibility in building models. Keras is a high-level API, often used with TensorFlow, and is easy for beginners. We'll use TensorFlow for our demo today, showing its power in action. These are tools to cast deep magic spells, simplifying complex tasks. They make deep learning accessible. I'm so excited to use them. Deep learning has incredible real-world applications, and I'm so inspired. It powers image recognition in self-driving cars and security systems, identifying objects. In natural language processing, it enables chatbots and translation tools like Google Translate. In healthcare, it diagnoses diseases from scans, improving patient outcomes with accuracy. It also drives recommendation systems on platforms like Netflix and Spotify, personalizing content. Deep learning transforms the world with its capabilities. It has a magical impact on society. I'm so thrilled by its reach. Transfer learning is a powerful concept in deep learning, and I'm so excited. It lets us use pre-trained models, like those trained on massive data sets, for new tasks. This saves time and requires less data, making deep learning more accessible. For example, we can use ResNet, a pre-trained model, for image classification tasks. We fine-tune it on our specific dataset to adapt it to our needs. It's a magical shortcut for deep learning, leveraging existing models. Let's use this AI magic. I'm so thrilled to try it. Before our magical deep learning demo, let's get ready like true wizards. Ensure Python, TensorFlow, and Scikit-learn are installed. Run pip install TensorFlow Scikit-learn if needed to have your tools ready. Use the customer's churn.csv dataset with age, income, purchases, and churn, or create it with the script in the description. Launch Jupyter Notebook by typing Jupyter Notebook in your terminal, opening your coding spellbook for the demo. Get ready to classify customer churn with a deep model. This demo will be spellbinding. I'm so excited. Now, wizards, it's time for a magical demo, deep learning in action. Sophia will use Python and TensorFlow to classify customer churn, predicting whether customers will leave, yes or no. This demo will build a deep neural network with multiple layers to make these classifications, showing deep learning's power. It's pure magic, and I can't wait to see it unfold. Over to you, Sophia. to cast this amazing spell.
Hi, I'm Sophia, your demo wizard for Wisdom Academy AI, and I'm so excited to cast this spell. I'm using Python and TensorFlow to build a deep neural network on a customer dataset with age, income, purchases, and churn, classifying who will leave. Show a 30-second clip of loading the dataset, splitting it, building a deeper model with more layers, training, predicting churn, and displaying accuracy, e.g., 85%. The magic of deep learning power is alive. Let's see the accuracy of our predictions. Back to you, Anastasia, with a big smile.
Wow, Sophia, that demo was pure magic. I'm so impressed by your skills. Let's break down how it worked for our wizards to understand the process. Sophia used Python and TensorFlow to build a deep neural network on a customer dataset, predicting churn. She loaded and split the dataset, built a model with more hidden layers, trained it, and predicted churn with an accuracy of 85%. The extra hidden layers allowed for deeper learning, capturing more complex patterns. This brings deep magic to life, showing the power of extra layers. I love how this works. Here are some tips for deep learning, and I'm so thrilled to share my wisdom. Start with shallow networks to understand the basics, then add layers to deepen. Normalize your data before training to ensure features are on the same scale, speeding up convergence. Use GPUs or TPUs to train faster, handling the heavy computation of deep models. Experiment with different architectures, layers, and learning rates to find the best setup. Keep practicing your deep magic to master it. You'll become a deep learning wizard. I'm so excited for your progress. Let's recap day 16, which has been a magical journey from start to finish. Deep learning uses many layers to tackle complex tasks, extending neural networks. We explored architectures like CNNs for images, RNNs for sequences, and transformers for language. We learned to train deep models with backpropagation and solved challenges like overfitting and vanishing gradients. Your task: build a deep neural network using Python and share your accuracy in the comments. I can't wait to see your magic. Visit www.oliverbodmer.eu DailyAIWizard for more resources to continue the journey. Let's keep mastering AI together. I'm so proud of you. That's a wrap for day 16, my amazing wizards. I'm Anastasia, and I'm so grateful for your magical presence on this journey. I hope you loved learning about deep learning as much as I did. You're truly a wizard for making it this far, and I'm so proud of your progress in AI. If this lesson sparked joy, please give it a thumbs up, subscribe, and hit the bell for daily lessons. Tomorrow we'll dive into convolutional neural networks, or CNNs. I can't wait to see you there for more magic. Sophia, Any final words?
Hi, I'm Sophia, and I had an absolute blast showing you deep learning in action with our demo today. It's been so inspiring to see how deep neural networks can unlock AI's potential for complex tasks, and I'm so thrilled to be part of your journey. Day 17 will be even more magical with CNNs, where we'll explore how they make AI see the world through images. Don't miss it, wizards. Keep practicing your deep magic, and I'll see you tomorrow with a big smile.